Whew, I am extremely nervous right now. I feel like I can't breathe, but I'm extremely excited to share this topic with you all. But first, I have something to share. Warning, right now, your users are at risk. Users of the web everywhere are frustrated in this very moment with the applications that they're forced to use every day. This is a review from the internet. Somebody wrote about their application. Hey, Amelia. Somebody wrote about their application. The new version sometimes slows down. This is a real user of a real web app. This is a real review, and it's from the internet, so we know we can trust it. And here's another review. Sometimes it takes a lot of time for loading the contents. Someone else simply wrote, it's too slow. This could happen to you, and this could happen to your users. But I'm here today to tell you that there is hope. My name is Will Klein. I'm from Boulder, Colorado, where I work at Workday as a full-stack engineer. This is my family. And I also have a confession to share. I have built apps that have reviews like these. And when approached with these complaints, I will initially reply, well, it works fast on my machine. But what about their machine? What about their browser? I use Chrome, but it turns out there's this other browser out there called Internet Explorer 11. And users everywhere are forced by their IT departments to use it, to use applications like mine. And it makes my life a living hell. And what about their connection? I have a very fast internet connection at home and at work, but not everyone has that. And not everyone has a fast VPN either. Sometimes their internet is fast, but when they dial into a VPN across the world, everything slows down a little bit. And what about their data? Have you ever seen a defect or a bug where the complaint is that their rich text doesn't actually render as rich text, but as HTML in a plain text field? Users do interesting things with our app that we don't quite anticipate all the time. And what about their data model? Some of our applications are configurable to the user or their organization, where they can change their data model to have any type of have different types of hierarchy. And this can lead to lots of performance woes that we can't very well anticipate. So there are many variables that work their way into our web app performance and our user experience. And this is a full stack problem. We can't just look at the front end or the back end. We need to look at the full picture and see what's happening throughout the system to know what we might need to do. And there are tools we can use. We can do performance audits on our application. We can do performance testing on our microservices. We can monitor our services and look at their response times. And we can even do application profiling on the front end and the back end to look for memory leaks and anything that might be slowing down. But none of these things look at what's actually happening for our users in the wild. So how do we observe our users' applications in the wild? How do we observe their actual user experience to know what's really happening in their conditions when they use our application? We're going to talk about that today and follow the full stack trace and learn how we can understand our app with the distributed tracing. Oh, my cursor's in the middle screen. I hate that. So this is Daredevil from the Netflix series. And Daredevil is a very interesting Marvel superhero. He's blind. But his superpower is that he can sense everything around him with his other senses. So much so that he's able to observe in an unprecedented way, despite lacking any vision. So I wonder if there's something that we can tap into that would give us a developer superpower so we can observe what's actually happening in the wild. I believe we can get that with distributed tracing. I'm going to zoom this just a little bit. So this is a trace. We're going to jump right into what this looks like. A trace is essentially a series of timings. And each row in this is a specific timing where a specific thing happens. And each of those things is called a span. In this case, the whole trace is following a user request. The user request is going to hit /dispatch with a HTTP GET request, and then a bunch of things happen after that. There's other HTTP requests associated with it to other endpoints. There's database calls to MySQL. There's access to Redis. There's a bunch of things that we can see happening when this request processes. Now, some of these things happen in parallel. The first 4 things in the blue and the yellow and the brown, they're happening in parallel. And that's good. They can happen at the same time. And then you see the next set of things happen afterwards. So some things are happening in parallel, and some things are happening sequentially. And this is interesting, because then we can start to see with this trace, at least in our backend here, we can see what is happening, how long is it taking, what can happen at the same time, and what's being blocked. And this is where we can start to see where bottlenecks are happening. This is also where we can start to see what actually happens when the user request happens. So this was shown with Jaeger UI from Jaeger Tracing. Jaeger is an open source project that is managed by the Cloud Native Computing Foundation. There's several members of the Cloud Native Computing Foundation that are sponsoring and supporting this project. So hopefully it'll be around a while. They have a number of other projects like Kubernetes, so they're doing pretty well. I was listening to this podcast last week. It was an interview with Yuri Shakuro, one of the main authors behind Jaeger. And about 12 minutes in, the podcast interviewer made a statement. Everybody wants distributed tracing. I stopped right there for a moment, and I started to wonder, how many of you have heard of distributed tracing before this conference? Woo, that's pretty good, but maybe half. Not everyone. And what I've found in my travels, particularly in front-end development, is a lot of people haven't heard of it. And if you don't work in enterprise software or an organization that maybe already has this on the back end, you might not have had exposure or the need to look at this. And the other interesting thing about this podcast is this was about 12 minutes in. They talked about microservices for the first 12 minutes. And that's actually where I think a lot of the content around distributed tracing is focused, is on the back end and how we handle the requests to our microservices. I want to look at that in a different way today. When I look at these front-end spans, the blue that you see here at the top, where it has a front end before it, these are basically identifying when the request came in from the front end. There's no other information about what happened in the browser to kick off that request. I want to go a little deeper there if we can. So how do we apply this to the front end? The first thing to think about is, well, what makes up a trace? When do we have a trace? What do we consider a user request? So I think about 2 things, really. When we're loading a page or doing a route change, we're loading a whole view, essentially. Or when there's any UI interaction of any kind. Maybe they're doing an inline edit, or they're doing a button click. Basically, any time the user interacts with the application, whether they're pulling it down for the first time, or navigating to another page, or clicking on a button, that is when we want to start thinking about what's happening. And that's a user action. And the other side to think about is the feedback that we're giving to the user. When does the page render? When has the UI state updated? When does the user consider it to have finished when they did something? This comprises the user experience, from page load to the page rendering, from the button being clicked to the view updating. This is what I want to measure and what I want to capture with my distributed traces. So when I go back to this, I want to take those blue front-end bars and enrich them with more child spans, more things that comprise those components. So I can know, what did they click? What happened in the browser before the request happened? When did it request it in the browser? And not just when did we get it on the back end. So how do we instrument our code? We're going to start with how we time stuff. Now, when I walk through some code examples here, I don't want you to get too hung up on the nuances of the code or any specific semantics. It's intentionally abstracted just to have the main idea of what is a trace, what is a span, how do we time things, and how we might bring that into our application. So our first example is, how do we start a trace? We need some API that lets us, well, start a trace and give it a description. Did we load a page, or did we navigate to a new URL? It might look something like this. We might give a description that we have a route change, and then we give it the slug. What is that window location that we're navigating to? And to record a span within that trace, more specific work that's happening in the system, for any of the work that we do, we want to time it again. And here we're starting a span instead of starting a trace. And then we want to do the work. We want to see whatever it is that we need to do. Could be anything right now. And then when that work is done, we want to stop the span. A quick example of that is maybe we're making a network request. Maybe we're making a request to a web service, and we need to start a span and record that it's a specific request. What's behind the API of start trace and start span? Not too much. Basic idea is you want to keep track of the trace that's active. So I have a let for the current trace. And then my start trace function sets that current trace to be a new object. And then it has a start time and a unique ID. With those two things, those are the main components of the trace. We need to know when it started and what is its identifier, because we're going to need that later. And start span is very similar. We just need to start the time for a given span and maintain a reference to it. For stopping the trace, we just record the stop time. We're just doing a new date, get the time, and putting that on the trace. And then, when we're done with that trace, when we've stopped it, we need to persist it in some way. This could be an HTTP request, but I do have a warning there. Initially, when you're getting started with this, making an HTTP request is great, just to see what's happening, seeing that on the wire, making sure you can thread that through to the Jaeger backend and that it pulls up in their UI. But eventually, you're going to want to have strategies to not create additional user web requests every time the user does something. So batching is a really good strategy to roll those up somehow and then send them all at once. So what does this look like in a real application? Maybe we're using React or Vue or Angular. This gets a little bit tricky. It will vary per application. I've done a lot with React. And even with React, there's React with Redux, there's React with state managed by React context. I might even be using Apollo client with GraphQL. And what this looks like in each specific implementation looks a little bit different. So we need to roll up our sleeves a little bit to see how we apply those APIs I suggested into a given application. But there's one common strategy that I advocate for. We could approach all of our UI components and all of our request code and instrument each one specifically, but then it's easy to miss things. So I like to opt into middleware or plugins wherever possible, so that way when I develop a new feature, it just gets picked up by the system, and middleware handles the timings for me. I'll show you a light example in Redux for this. The bit I want to focus on here is in Redux, or really a lot of middlewares, there's this concept of a next function. And the idea is that you can do things in your middleware when you're processing requests, when an event has happened. You can do it before actually acting on that action, and you can do things afterwards. So in the case of tracing, we want to start a span before, say, hey, we got a Redux action, here's its type, and then we call next. And when we call next, it's going to process it, it's going to actually pass it through the system. Other middlewares can act, and eventually Redux state can update. It's the same for other state management systems. And then after that, we can stop the span and record when we finish that. We also need to make this full stack. I talked about not just having the backend spans, but connecting it to the front end. To do that, we need to share the trace that we create on the front end with the backend. I'm going to use a plugin example here. I'm using SuperAgent. SuperAgent has an API similar to, I think, Redux middleware and Express and Koa have something similar. When you plug in a middleware, you say, hey, use this middleware. Well, with SuperAgent, to use a plugin, you can define, hey, here's what my GET request is. And I can say use for a number of plugins. And I will say use my tracing plugin. And then here's the response body, pass that back. Now, tracing plugins, similar to the Redux example, the middleware example, a little bit simpler though. We take in the request for it, and we can set things on the request, like headers. So we can go and get the trace that we manage, and then get the trace ID and put that on as a request header for the request. So when we send that to the backend, our backend code can say, hey, is there already a trace ID existing? And if it is, we'll create spans and associate it as children of that. Does this work? What does this look like in a full stack application in a real world example? I have another confession. I've been working really hard to come up with a demo for this, but I wasn't able to do that in time. It's not trivial, but the value is incredibly high. I'm pretty close. I'm very excited to share this with you soon. In fact, the current state of tracing in the front end, doing it full stack, is, well, there's help wanted. There's a repository called Jaeger Client JavaScript that's under the Jaeger Tracing project. And there's no code. But there's one issue. Extract the base JavaScript client from Jaeger Client node. So Jaeger Client node is an existing NPM module that you can pull in on a node backend and get a bunch of utilities for starting traces and starting spans. But it's right now coupled to node. And so there's some help wanted to take out the node bits and make something that's browser friendly. The current state of that is that nobody is working on this at the moment right now. But there's multiple people before this and after this comment saying, hey, we need this, we want this. So I think this is going to come up more and more. A very common case is that you already have this in your backend, or that your backend developers will bring this into the application first. And you see that opportunity, they're already solving the infrastructure problem, and it's something to look at bringing it into the front end. But there's more benefit that I think is behind this than just finishing what the back-end developers might be starting. Trust me, it is possible. So 5 years ago, I was at a company that had this. They had full-stack traces with a pre-React legacy front-end framework. And when we migrated from that framework to React, we were able to look at traces on the old framework and React as well, and see the differences, and see what was improving, and even what was taking a step back. So we were able to, when we migrated into Flux and eventually Redux, we were able to look at where were our bottlenecks in the front end and address those things. It is definitely possible. I know a number of companies have hand-rolled their own, but right now we're starting to see this come out in open source with Jaeger tracing, and now we're going to see it soon in the front end, I believe. There's another project out there called Real World I/O. And this is basically, it's like a new to-do MVC. It's been around a couple years. But they basically have implemented React examples and Angular examples and Vue examples. They've basically taken any of the frameworks that are out there and tried to implement a Medium blog clone. And they've not only done the front-end clones, front-end implementation examples, but they've done back-end examples. So I'm actually working on a real-world I/O fork right now and trying to create examples of this with the full stack. So stay tuned. So when I think, again, about our users and how we can observe what's really happening in the wild, I can tell you it's amazing being able to see an actual trace that shows, like, this didn't perform the way I expected. And being able to see things that happened that I didn't expect as well. Because when we look at our traces, it's actually not just about performance. When I look at this, I can see everything that's happening in the system. And if I include the front-end activities as well, then everything in a potentially complex distributed system is apparent in one view. Not just what is happening, but how long, what's blocking what, and what can I improve about this? And being able to see this happen in the wild with actual user requests, that is amazing. And with that, we can better understand our apps. This can be an incredible tool, not just for debugging performance, but for onboarding new developers, for seeing how different parts of the system that we haven't worked with yet work. So check out Jaeger Tracing IO. There's a really good place to start there. They have an all-in-one Docker image that you can pull down, and when you run it, it runs all the things you need to aggregate and receive requests for tracing, and then view them in their UI. And I'll share some updates on Twitter. Follow me at Will's Lab, working hard on that real-world example to share with you all. And I'll be around for any questions. Thank you all for listening. It's been a blast to share this with you, and I hope to discuss this more with you in the future. Thanks.